So this is the first rod and this is the second rod. Full screen not there? Okay, you want full screen. B bar into the plane. These are again take help of some very good application problems are there. So this is initially a test, rod 1. This is given velocity V naught. It's asking what conditions will arise here. This is a rod 1, rod 2. B bar is present everywhere. And now when you give velocity V naught, negative flux increases defined by negative EMF induced, positive induced current will flow anti-clockwise. The induced current will flow anti-clockwise, and because of that, here in what direction the current will flow? So I'll starting the explanation. I'm starting from here. So the induced current when the rod has come to this position. So what is the direction of induced current? Will be like this, and because of this, the velocity of this rod starts decreasing, and the induced current I is flowing on this. So because of this current I flowing B bar into plane, so it will experience a force. So how much of force? BIL. Here BIL will be like this. So then this will acquire a velocity V2. So initially V1 will be less than V2, but V1 will be greater than V2. Tell me what will happen. How long this motion of rod like this will take place? How long the motion of rod like this will occur? Because of BL force, continuously velocity of the rod 1 will keep on decrease. The velocity of the rod 2 will keep on increase here. At one instant both will have common velocity. And once both have common velocity, then what conditions will arise? Both will have common velocity, then the net flux linking the loop remains constant. Though there will be displacement of rod, net flux linking the loop remains constant, and because of that, no induced current will flow. What should happen to the distance between the loops must increase. Distance between the rods will increase. So you calculate initial distance, say some x naught. This should be x, and this x should be greater. They may ask you any very good conceptual questions. Finally, both will have common velocity. So let mass of the rods be m. Can I conserve momentum? Can I conserve momentum? Yes. What is the net force on the system along x-axis? 0, no? So initial momentum mv naught should be equal to mv plus mv. So v equal to v naught by 2. Initial kinetic energy of system m v naught square by 2. Final kinetic energy of system of mv square of mv square. So this should be mv square or mv naught square by 4. Now I am asking you kf less than kf. Where do this energy gone? What type of motion the rod 1? Retarding motion. So where do that decrease in kinetic energy of system has gone? Momentum of system will not change. Momentum of system will remain same as it is, but kinetic energy of system here decreases because net force on system along x-axis is 0. So therefore I'm conserving momentum. Where do that energy gone? So something we should justify, no? Kf less than k, loss in kinetic energy. So what are the possibilities? There should be some resistance. The rods will have some resistance, and that particular heat will be generated. There's only source, no? Or else if you go for any other friction is there between the rails and the rod, they'll be utilized to overcome that friction. Anything. So now delta K should be equal to heat generated. They're the possible source. So let me put some resistance for the rod. Very good questions can be asked. I'll connect spring between the rods and I'll project it. You go for further thinking on this one. Now similarly,